Hello, my dear students. Let's start. Today topic is derivation of the law of conservation of linear momentum from Newton's second law of motion. To derive one derivation of linear momentum, which is comes from the Newton's second law of motion. What is meaning of conservation? We have already know about energy conservation, neither create it nor destroy. It's only transfer from one form to another form. That is energy. It means what? Conservation in the sense linear momentum, whatever they are in a state, they want to conserve his state. It means simple we can say that जिस कंडीशन में कोई सिस्टम के अंदर जो पार्टिकल हैं और अगर उस पर कोई एक्सटर्नल फोर्स अप्लाई नहीं किया जा रहा है वो उसी कंडीशन में रहेंगे जिस तरह की वो पहले से हैं। तो यही है कंजर्वेशन ऑफ लीनियर मोमेंटम इन द सेंस कि अगर किसी बॉडी के अंदर जो पार्टिकल्स हैं वो कंजर्व कंडीशन में है। सो लेट्स स्टार्ट फ्रेंड्स। फर्स्ट ऑफ ऑल वी हैव टू अंडरस्टैंड व्हाट इज ए conservation law says that when no external force act on a system of several interacting particles, the total linear momentum of the system is conserved. When no external force acts on a system of several interacting particles, the total linear momentum of the system is conserved. Simple. The total linear momentum is the vector sum of the linear momenta of all particles of the system. It means no external force acts. What is meaning of isolated system? Isolated system means that type of system which have no any external force act. Okay. So now any system has number of number of particles, and n number of particles has mass and velocity mn and vn. So now we have what we know about the linear momentum. Linear momentum says that mass into velocity, where velocity is vector quantity, so linear momentum is also vector quantity. So we have to number of linear momentum, number of particles. So suppose that first particle has mass 1 and velocity also 1. Again second particles have linear momentum p2, mass 2 and velocity v2. As like that, number of linear momentum has mass n and velocity n. Okay. So now we have linear momentum, number of particles, that is p1, p2 plus p3 plus number of particles of linear momentum, that is pn. Okay. So now what we know about the second Newton's law of motion? We know that second law of motion says that force is directly proportional to linear momentum of rate of change of linear momentum. Simply. So we have taken isolated system. It means no any force acting on that system. So force will be 0. So linear momentum also become zero. It means constant, constant. We get the conclusion, conclusion if no any force act on the system, then linear momentum of of that system is conserved. सिंपल. अगर कोई फोर्स ही एक्ट नहीं करेगी किसी सिस्टम पे, तो उस सिस्टम के जो पार्टिकल्स हैं वो क्या करेंगे? वो लीनियर मोमेंटम क्या होती है? लीनियर मोमेंटम होती है जो उसकी पार्टिकल्स हैं उसकी वजह से जो मोशन हो रही है, पार्टिकल की मास और वेलोसिटी की वजह से जो मोशन हो रही है. तो अगर एक्सटर्नल फोर्स ही अप्लाई नहीं होगी, तो उनकी जो मास, किसी भी पार्टिकल की मास और वेलोसिटी है, वो जैसी है वैसे ही रहेगी. इट मीन्स वो पूरी सिस्टम कंजर्व रहेगी. हेलो माय डियर स्टूडेंट्स, अगेन आई स्टार्ट वन मोर डेरिवेशन, law of conservation of the linear momentum from Newton's third law. Previously we have derived one derivation for law of conservation of linear momentum from Newton's second law. Now we are going to derive one more derivation for law of conservation of linear momentum for from Newton's third law. What we know about the third law? Newton's third law says that every action has opposite and equal reaction when they will be interact. So let's we will derive. Suppose body A and body B, mass m1 and its mass m2, initial velocity u1 and its u2, going a straight line. Okay, same, moving in a straight line, and initial velocity u1 is greater than u2. So what happen after some time delta t? They will be collide. Okay, so it's forces acting on the A due to B, and forces acting on the B due to A. Okay, after collision, same. What happen? They will be again A body, B body, m1 mass. Mass will be not change. Mass will be no change, but velocity will be change. It will become v1 and it will become v2. Okay, so what we know about the Newton's third law? We know that force AB is equal to minus force BA. Every action has opposite and equal reaction. Okay, so now of force AB. What do we know the formula of impulse? Impulse is equal to force into delta t. याद कीजिए महेंद्र सिंह धोनी का वो सिक्स, बैट और बॉल का कॉम्बिनेशन. स्मॉल टाइम के लिए हाई फोर्स लगाना, दैट इज ए इम्पल्स. तो फोर्स इनटू टाइम. ओके, तो फोर्स इनटू डेल्टा टी is equal to change in momentum of a body. That is m1 v1 minus m1 u1. Now again impulse force ba, that is force impulse into delta t is equal to change in momentum of body b, that is m2 v2 minus m2 u2. Now what we know about the Newton's third law? We know that force of A due to B equal to minus force of B due to A. So put the value of force of AV, that is M1 V1 minus M1 U1 equal to minus M2 V2 minus M2 U2. It will become M1 V1 plus M2 V2 equal to M1 U1 plus M2 U2. Velocity is vector quantity, so we have to write down vector. So after collision equal to before collision, before collision of linear momentum of equal. So linear momentum is conserved. When we apply the Newton's third law of motion, we have seen that law of conservation of linear momentum.